Welcome to the last lesson in Unit 8. Kind of warned you that this was coming. I think it's going to be okay because I think it's going to give some meaning to the last lesson. I think which will be good. So we're going to do some proofs, not old school proofs like you're used to with the 2 columns and all that. You'll see what they look like here in a little bit. They're not as bad. But before we get started, I'm going to show you how what we did yesterday applies to today. So name the formula needed to prove the following properties, which we've talked about all of these properties. If I want to show opposite sides are congruent or have the same length, what would I show? What formula would I use? Hopefully you pick up on what we did yesterday. That would be the distance formula. How would I show that opposite sides are parallel? Well, how do I show 2 things are parallel? I need to look at their slopes. How would I show that 2 diagonals are perpendicular? We talked about that property in rhombuses and kites. We would show slope again. Perpendicular deals with slope. And how would I show that diagonals bisect each other? This one's a little bit harder. I'm just going to tell you now, and we'll talk about it in a little bit. That's midpoint. So we talked about all 3 of these formulas yesterday. Now we're going to use them to prove either properties of something on a coordinate plane or to help prove that something is a certain figure. So here we go. Prove that the following figure is a parallelogram. I'm going to show that this is a parallelogram. What is the definition of a parallelogram? 2 pairs of parallel sides, right? That lesson 1 should know that by now. 2 pairs of parallel sides, or opposite sides. Okay. Which formula are we going to use to show parallel sides? We're going to do slope, and we're going to have to do it 4 times. All right. We want to show that DC is parallel to AB. We want to show that. We also want to show that DA is parallel to CB. So what do I have to do? I have to find the slope of each of those lines. So let's start with DC. So DC, let's find the slope using the slope formula. Y2 is 2B minus Y1, which is 0, all over X2, which is 0, minus X1, which is negative 2A. Simplify that down, you get 2B minus 0 is 2B. 0 minus negative is plus, so that's positive 2A. The 2's cancel, and I'm left with B over A, which means nothing right now. But the slope of DC is B over A. Now let's look at AB. We want to show that these 2 things are parallel. So hopefully the slope of AB is also B over A. Let's check. So AB, it doesn't matter which one's X2, we'll just say A is X2. So 0 minus negative 2B over 2A minus 0. 0 minus negative is positive 2B. 2A minus 0 is 2A. The 2's cancel again, and I'm left with B over A. Well, what does that mean? It means that DC is in fact parallel to AB, which is great, but I still need to find the slopes of the other pair. So all I've shown right now is that this and this are parallel. I now need to show the other ones. So I'm going to look at AD. So X2, 0, minus 2B over 2A minus 0. So that's negative 2B over 2A. 2's cancel again. I'm left with negative B over A. And then I'm going to do last one, BC. So B is negative 2B for Y2 minus 0 over 0 minus negative 2A. Negative 2B minus 0 is negative 2B. 0 minus negative, it's positive 2A. Sure enough, negative B over A. And now I can say that these 2 lines are, in fact, parallel. In doing all that work, I've proven that these 2 but the opposite sides are parallel. Therefore, this is a parallelogram. So what you would do is summarize that at the bottom. That's what I'm going to do down here. Since both pairs of opposite sides are parallel, I can conclude that the figure is a parallelogram. It is important that you do this summary sentence. You have a lot of work up there. It's going to be a lot of like scratch work almost, but you need to explain what you did. Okay, that's going to be checked on your test. All right, so keep that in mind. You'll see it a couple more times with these last two proofs. All right, so next one. Prove that the diagonals of this parallelogram bisect each other. I know I said it on the front. How do I show something bisects? Well, first of all, think about what bisect means. Bisect means to cut in half. Half is your clue. Halfway through a diagonal is the midpoint. How do we show? We want to find the midpoints. Okay, so MT, the midpoint of MT should match the midpoint of RE. If the midpoints are the same, then we know that they bisect each other. So we want to find the midpoint of MT and RE. So let's start with MT. We have all the coordinates there, which is nice. So MT, so A plus A divided by 2, and then 2B plus 0 divided by 2. So that's 2A over 2 and 2B over 2. Divide by 2, I get A comma B. That's the midpoint of MT. Now let's do RE. Well, 2A plus 0 divided by 2, 2B plus 0 divided by 2. I get 2A over 2 and 2B over 2. And I get the 2's canceling, so I get A over B. So the midpoint of RE is A comma B, which is the same as the midpoint of MT. So what I'm going to do is I'm going to type this actually. So you want to summarize what you've just said. Since the midpoints of both diagonals are the same, that means the diagonals bisect each other. And so I've just proven that theorem. Okay. Get rid of that. We'll do the last one. Prove that the diagonals of this rectangle are congruent. So how am I going to do this? Well, the diagonals being congruent means they have the same length. So how do we show length? Use the distance formula. And how many times are we going to have to do it? In this one, we're going to have to do it twice. Let's say I wanted to show something was a rhombus. I would have to show all four sides of the same length. I would have to do the distance formula 4 times. All right, so this one only twice. Let's do BD first. You could have done AC, it doesn't matter. So distance formula, it's x2, so k minus x1, 0 squared, plus 0 minus m squared. Now we simplify. K minus 0 is k squared. 0 minus m is negative m squared. But negative m squared is negative m times negative m, which is positive m squared. So my distance is k squared plus m squared. Stop there. That's BD. Now let's do AC. So that's k minus 0 squared plus m minus 0 squared. I think you can probably guess what we're going to have here. That's k squared plus m squared. Don't have to do any simplifying. They match. So my summarizing sentence, last thing we're going to do here, make sure you do this. All right. since the diagonals are the same length, they are congruent. That's it. That is all you need for your summarizing sentence for this one. Okay. And that is coordinate proofs. I know it's not easy, but you should be able to do these things. It's using the properties that we've learned in the first 5 lessons and applying them to a new situation. So that's it.